Okay, we've been talking about a straight wire causing a magnetic field in the space around it. So if I have a wire like this, with the current going to the right, we use our right hand rule. Current's going to the right, my fingers wrap around that wire, and they'd be coming out of the page above the wire, and then into the page below it. So I could draw the magnetic field like this, out of the page above the wire, into the page below it. Now, something you can do to strengthen the field is to turn the wire into a loop. So let's say I have a loop of wire like this. This is connected to the positive side of the battery. This is connected to the negative side of the battery. Now, what's going to happen is we have to remember current is defined as positive current flow. We know there's actually electrons coming from the negative side and being attracted to the positive side. We define current as going the other way. So our current is going to be like this. Now, if we look at this point right here, current's going to the right. So using this right hand rule, the current's going to the right. Our fingers go into the board below and then out of the board above the wire. So I would have a magnetic field into the board here and out up here. Now, what if I look at this point over here? Now the current's going down. So my thumb has to point down. My fingers go into the page and then come out of the page on the other side. So into the page on the left side, out of the page on the right side. So I have into the page over here and out of the page over here. For the bottom, current's going left. My thumb points to the left, fingers into the page above the wire, out of the page below the wire. So they're into the page up here and out of the page down here. And what we find is everywhere in the center of the loop, the magnetic field is going in the same direction. In this case, into the page. So that's going to add up and give us a little bit stronger magnetic field. Now, I can do this right-hand rule that I've been doing all the way around, okay, and figure out what the magnetic field is. But there is a right-hand rule for loops that we can use as kind of a shortcut. For that, we make our fingers wrap in the direction of the current, and our thumb is the magnetic field inside the loop. Okay, so let's do a different example. Let's say this time I hook it up and I make this side negative and this side positive. Okay, my current is going to come out of the positive and flow around this way. Now, using the new idea of the right-hand rule, I'm going to take my fingers and wrap them around the direction the current's going, and then my thumb is pointing out of the board if I do that. So I know the magnetic field is going to be pointing out of the board. The way I kind of think of it is this. If the wire is straight, my thumb is straight, and the magnetic field curls around. If the wire curls, then my fingers curl, and the magnetic field is straight. That's my thumb. Now, the reason this becomes important or powerful is if I wrap numerous loops instead of just one little loop like this. If I wrap it around and around and around, the strength of the field is directly proportional to the number of loops. So if I have 10 loops, I'm going to get 10 times as strong a field. Something called a solenoid is like this. It's a coil of wire wrapped around a core. And we'll do that for this one. We'll do an example. We'll have this core, and then we're going to wrap the wire around it. So the wire is going to come up behind it and then wrap around down in front. And just keep doing that. It's coming up behind it and wrapping around down in front, for instance. And we'll make this the negative side, this the positive side. So the current's going to go up behind and then down here in front and down in front. Okay? So like this. So if that's the case, what's going to happen is my fingers do what the current does. So my fingers are curling around this way. Okay, and then my thumb is pointing out this way. So my magnetic field points out this way, and it would come in on this side. And it turns out this just acts like a bar magnet, because the magnetic field lines are going to come out of here and curl around into there, just like you would find for a bar magnet.